Welcome. In this video, we'll be talking about distances. Distances are the distance between something. Like for example, how far away point A is from point B in a 10 by 10 grid. Now, there are three methods we can use to establish this. Number one is Euclidean distance. Number two is Manhattan distance, and number three is chess distance. These methods all have their applications. Like for example, we can take Euclidean distance. As you can see, Euclidean distance has three main methods in 1 and 2 dimensions. It also has a 3-dimensional method, but we'll talk about that later. So we see the first method is that the Euclidean distance in 1 dimension is equal to the square root of P, the first point, minus Q, the second point, squared, which is basically meaning that the absolute of them, so the square root of absolute. And for 2 dimensions, we actually have 2D coordinates passed into this so-called distance function. So it's the square root of Q1, which is the first point x, and minus P1 squared, which means the absolute values of the x's, plus Q2 minus P2 squared, which means the absolute values of the y's. So I think the square root of the absolute value x, absolute value y. We also have the polar coordinate, which is the radius squared here, and there are other variables to this, as you saw, and you can just plug these variables in and you can see what happens. Then, in my next section, we are going to talk about higher dimensions. Now, in 3 dimensions, it's going to be the same thing, but guess what? With 3 points. So Q is a 3-dimensional coordinate, and Q is also a 3-dimensional coordinate. So we're going to look this from a practical point of view, where we have 1 dimension. So that would be 2, as you've seen on that picture. So we are taking the square root of 4 minus 2, or 2 minus 4, but it has to be absolute, so no negative numbers. So 2 minus 4, we are absoluting everything, so that's our safety check. And as I'm saying, we just need to get the distance, so we don't need to know anything about if it's in front or if it's behind. We just need the distance. So to perform the square root of 4 minus 2, which is 1.4, this square root of 1.4, it can be rounded to 1, so it's approximately 1 unit, which is correct. So if we actually plug this with the parameters you've given, we actually get an answer of 13. So our point A, point B are 13 units away, and we can use this for varying things. Like if you want to use something, like for example, you want to get the distance from one point to another on, let's say you're making a maps application and you want to know the distance between the 2 points, you can then use that formula, and it can be very useful. And as you continue, we're going to analyze it, and we're actually going to implement a distance counter in the web. So you can use in Pygame or in any platform really, and we can use these concepts to build a distance application. And so without further talking, let's get right into it. So when we're talking about distance, we're talking with Pygame. Normally we have Pygame vectors. Now in Pygame vectors, we have a distance to function, which we'll use. So we first need to import Pygame. Once we import Pygame, we should initialize it and make sure you also import the system and random modules. Then we set our distance to our initial value of 0, and we initialize our screen. Then we set up our clock, and we also have a font, and I'm using Arial in this case. Then we just loop over all the events and check for exiting. Then after that, we use vector tools from Pygame to create a random one from 20 and 800 and 20 and 600 for the X and Y's. Then after that, we create a text by making it a string distance. Then after that, we figure out the distance by calculating the distance to position 2. Then we draw a circle on the screen at that position, and it's going to be white, the radius of 40. So this is basically the whole application. Manhattan distance is similar to Euclidean distance, but it uses a taxicab geometry. That means everything is gridlocked, so you just can't go in a diagonal, like a normal grid, but you have to use directions. So this means that equation to Manhattan distance, the root of the x's plus the absolute of the y's, no square root anything involved, because that's going to make it pick the shortest distance. So when you are using the taxicab geometry, this can be something like very good in a dense area.